Hello everyone, this is Dr. V. Naganjanelu, Associate Professor, Department of Mathematics, Vardhaman College of Engineering. Present topic is maximum and minima. What is maxima and minima of function of two variables? A function f of xy is said to be a minimum value at x is equal to a, y is equal to b if f of a b greater than f of a plus h, comma b plus k for all positive or negative small values of h and k. Now a function f of x is said to have minimum value at x is equal to a, y is equal to b if f of a b less than f of a plus h, comma b plus k for all positive or negative small values of them. Here the main difference is when it is maximum you are targeting the greater than, when it is minimum you are targeting the less than value. Let us see the diagrams. A small diagram, figure 1 shows here the maximum value here and here minimum value, and the third figure shows saddle point. It's like neck of the horse there. Conditions for maxima and minima of function of f of xy. The necessary condition is f of xy is to have a maximum or minimum at a comma b such that dou of a comma b dou x is equal to 0, means first partial derivative is equal to 0 with respect to x and first partial derivative with respect to y is equal to 0. From this you will get the stationary point. What is stationary point? The point AB is called a stationary point if fx of AB is equal to 0, fy of AB is equal to 0. First partial derivatives with respect to x at that point AB, with respect to y at that point AB is equal to 0. What is extreme value? A value is said to be extreme value if it may be maximum or minimum value. Working rule to find maxima and minima values of f of xy. We have certain rules and regulations. First one, you have to find dou f by dou x and dou f by dou y and equate to 0. If you solve those equations, you will get stationary points. Those I am taking here, a1, b1, a2, b2, a3, b3 like that. Second case is calculate second partial derivatives, namely r is equal to dou square f by dou x square, s is equal to dou square f by dou x dou y, and t is equal to dou square f by dou y square at each of stationary point. Third case, find rt minus s square is greater than 0 and r less than 0 at a1 b1, then f has a minimum then f has a maximum at a1 b1 and f maximum is equal to f of a1 comma b1. If rt minus s square greater than 0 and r greater than 0 at a1 b1, then f has a minimum at a1 b1 and f minimum is equal to f of a1 comma b1. If rt minus s square is less than 0 at a1 b1, then f has neither maximum nor minimum at a1 b1. That is, a1 b1 is called a saddle point, means neither minimum nor maximum. If rt minus s square is equal to 0 at a1 comma b1, then no conclusion can be drawn in this case about maximum or minimum, and it needs further investigations. So these are the three steps we have to follow. So mainly you have to work on first partial derivatives and make equal to 0, find the stationary points. Later find second partial derivatives and work with rt minus s square. Now start the problem. Examine the maximum or minimum values of f of xy is equal to x power 4 plus y power 4 minus 2x square plus 4xy minus 2y square. Now the task is you have to find first partial derivatives with respect to x and y and second partial derivatives with respect to x and y you have to find out. The first one, what is fx? When you think about fx, look at the where x is available. Here x is available and here x is available and here x is available. Three places. There only the changes will come. 4x keep. There is no x. It will become 0. Minus 4x. Here x is there. Plus 4y. There is no x. It will become 0. Then what is fy? Now with respect to y purely, here y is available, here y is available, here y is available, so it will become 4y cube plus 4x minus 4y. These are the first partial derivatives. Directly you find here only second partial derivatives also. R is equal to f double x. One more time with respect to x. X is available here, 12x square minus 4, and let's move the t is equal to f double y. One more time with respect to y, you will get 12y square minus 4, and in between I need s value which is fxy. It gives fx with respect to y. This fx with respect to y, where is the y is available? Here, so it is the 4. I found first partial derivatives fx and fy, and second partial derivatives are s and t. Let's to find stationary points. Equate fx is equal to 0 and fy is equal to 0. You will get this one. 4 common is there, you can take out later also. 4x cube minus 4x plus 4y is equal to 0. Here 4y cube plus 4x minus 4y is equal to 0. Now let's see, 4 is common, take it out. X cube minus x plus 4 is equal to 0. Y cube plus x minus y is equal to 0. By solving these two equations, if I take this as 1 and 2, you will get బోర్డు జరిగింది అది పైకి అనాలన్నా ఇది పోయింది కదా బోర్డు పైకి వెళ్ళట్లే. Now taking 4 common, you will get x cube minus x plus y is equal to 0, and here also y cube plus x minus y is equal to 0. Take it as first equation and it is second equation. Solving 2 means I am doing 1 plus 2, you will get minus x plus x will be cancelled, plus y minus y will be cancelled. You will get x cube plus y cube is equal to 0. Then x cube is equal to minus y cube. By solving this, you will get x is equal to minus y. This x is equal to minus y, substitute any one of these equations 1 and 2. I am substituting in equation 1. We get x is minus y or y is equal to minus x. You can do that. Substitute in 2. We get y cube minus y is equal to 0. Then y cube is equal to 2y. Y cancel, 1 of y, and y square is equal to 2. Then y is equal to plus or minus square root 2. As we know that x is minus y, then you will get, if y is plus 2, then if y is plus square root 2, then x is minus square root 2. If y is minus square root 2, x is plus square root 2. Therefore, the stationary points x, y is equal to, you will get square root 2 comma minus square root 2, minus is available, and minus square root 2 comma square root 2. Once you get stationary points, let's substitute in the second order partial derivatives rt minus s square. Now rt minus s square is equal to, so what is r and what is t, what is s square? We got here r is 12x square minus 4, t is 12y square minus 4, and s is 4. Substitute there, 12x square minus 4, 12y square minus 4 minus 4 square. I substituted r value, t value and s value. So first stationary point I am substituting at, what's the value? Square root 2 comma minus square root 2. I am substituting, this is the x value, this is the y value. We get, so 12 into square root 2 whole square minus 4, 12 into minus square root 2 whole square minus 4 minus 16. We get 12 into 2, 24 minus 4, 20. Here also 20 minus 16. then 400 minus 16, we get 400 minus 16, 384. So which is greater than 0? According to third condition, if rt minus s square greater than 0, then we have to think about for r value. What is r value? We have and r is equal to 12x square minus 4. In this you are going to substitute square root 2 comma minus square root 2. You are going to get this as here 20 finally is equal to 20, which is greater than 0. Please concentrate here. R is greater than 0 we got, and rt minus s square greater than 0 we got. When r is greater than 0, then f has a minimum value at this point square root 2 comma minus square root 2. Similarly, if you substitute minus square root 2 and plus square root 2, you will get the same concept. Why? Because only x square y square is there, so square root of that will come same, and you can write like minus square root 2 comma square root 2. Thank you all.